All right. So a couple of you guys did ask.
Yes.
Excellent. Let's get some data here. Okay, so let me keep track of all the board real quick and I'll throw it all in the machine. Andrea, how many did you ask altogether? 31. Okay. So we'll have X and we'll have N. So you asked 31. How many couldn't find it?
6.
6 couldn't find it. All right, great. Jason, you
Wait,
said
no. Other way around. 6 could find it.
6 could find it. The other ones couldn't. So that's
Yeah, 25.
25.
Yeah.
All right. So I'll put that up here. Couldn't find Iraq. Okay. Good. Angie, you did too? Go ahead.
I did 4.
4 people.
3 could not find it.
3 could not find it. Excellent.
8.
8.
And all 8.
And all 8 couldn't find it. Okay. Anybody else?
I did 10 people and 2 couldn't find it.
2 couldn't find it. All right. 2 and 10. Beautiful. Good variability. Good variability. So 8 out of 10 could. 100% couldn't. Good variability. Anybody else get some? Let's put this in. Now, this was the data we ran yesterday. No, it's not. 16 out of 44? That got changed because there weren't 44 people in class yesterday. What do we have? Oh, does anyone still have it in their machines? I probably don't. Damn it, how did it change? I haven't run one of these since Monday. Do you still have it yours, Andrea?
Yes.
Good. What is yours?
0.197, then 8, and then 22.
8. That makes a lot. Oh, I know why. I know why it said 16 and 44. We were talking about the margin of error and how it shrinks with a larger sample size. So I doubled everything. That's right. It was 8, 22, 16 and 44. Okay, whew, that makes more sense. And we were just trying to see if you guys were different. So this was our original value. It looks, whoops, let me turn all that other crap off. Hang on. Don't need that stuff on. All right. So a little bit of error. Looks like, and this was fun because it snuck in just under 5%, which means it does look like you guys are different. But then, of course, the argument is it's so close to 5%, and 5% is somewhat arbitrary that maybe we should look at it. Maybe we should look at more data, which I was so thankful you guys went and got me some more. This is fantastic. So what do we got here? We got 18, 22, 53 more, and of those, 35, 38 couldn't find it. Let's just add your data to ours. Make a grander sample, if that makes sense. All right. So we're still testing the same hypothesis that they can't find Iraq, or whoever we're testing right now. I'm not sure what our population is anymore. People, us, and people we know. That's our new population, whatever the hell that's worth. So we're gonna adjust the sample size. It was 22. We're gonna add 53 more to it to get to 75. All right. And then 8 is going to become 46. Fair enough? That's a pretty large percentage. That's over half. So it's definitely different than 20%. The question is, how significantly different is it? Okay, here we go. Oh, I don't see any area at all. Look what it's saying. It's saying the p-value is 0. Now, it's not 0. It's not. It's just rounding to 0. Now, if you want an indication of how unusual your results are, look at the actual test statistic. That z equals 9, right? What does that mean again? Z equals 9. It's a test statistic, sure. But what is that actually telling you? 9 what?
9.
Say it, Jamie.
Over 9.
9 standard deviations! You got it, it's over 9. And I like where you were going, Jamie. You were going this way. This way, 9. Actually, this is too big. Let me make it smaller. Hang on. I need wireless. Let's put this guy here. Alright? Is that gonna do it? Nope, that won't be good enough. Okay, back up, I'm out of cord. We'll have to make do. We'll have to make do with the size of this thing the way it is. Alright. So, what this means is, if the results we got, us plus our neighbors and our friends and whoever else you guys asked, if those people actually belong on this curve, they wouldn't be here. They wouldn't be, they wouldn't be here. They wouldn't be here, 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 they wouldn't be here. They'd be like here. That's 9 standard deviations over. Every one of those tick marks is a standard deviation, yes? Every one of those tick marks is a standard deviation. So we're 9 standard deviations. How do we know we went this way and not that way? Because it's positive. And we kind of had an indication of that before we even pressed draw, because we had 46 out of 75. That's over a half, yeah? That's over a half. Now, I know this is 0 right here, technically, but what percentage is actually being indicated right there at that 0? 0 is the standardized, normalized, negative number of standard deviations. What percentage is in the middle of this whole test? What were we testing against? 19.7. 197. So our, whatever we got, I didn't check the p hat value. Was it like 60% or something like that? I'm gonna run it again. I'm gonna run it, but I want to calculate this time to get the actual percentage too. Okay, there, yeah, 61%. 61%. That's a hell of a lot different than 20%. And the reason it's a hell of a lot different, and the reason, oh, here's a p-value, is not calling it 0 anymore. It's calling it 1 times 10 to the negative 19th. You can see why it's rounded to 0. To 4 decimals, it is 0. So in other words, this 61%, and it's super significant because your sample size is now so large. If we got 61% with a sample size of 5, I wouldn't think twice about it. I'd say go collect some more data like you guys did. But the problem is, when we did the, can I get a graph? Yes! The problem is, that 61% is way the hell over here, and that curve is somewhat tall. That curve is somewhat tall, which means that we're probably not on it. We're probably on some new curve. Where's the new curve center? Be as precise as you can without being too precise. Where is the new curve center? Don't give me a number because you can't. But where is the new curve center? If we landed over here with our data, assuming our sample was a good sample, which I'm not entirely sure it was, because who'd you guys ask, just out of curiosity?
Other students.
Other students! Fantastic!
And then 2 of them were my children,
That's excellent! How old are your kids, just out of curiosity?
7 and 10.
They probably know geography better than I do, guaranteed. Yeah, I guarantee. Couldn't find Canada one
They
day.
were my 2.
Oh, for God's sake. It's okay. So, I'm not saying our sample was very random, representative, whatever. I'm not even sure who our population is. But the point is, where is the center of the curve? Is it close to that curve? Is it left of that curve? It's most definitely over here somewhere, probably pretty far, put that in quotes, pretty far from the center of that curve. Now, we got 61%. Chances are it's fairly close to that. Again, whatever population we're studying, I have no idea what it is, but chances are the center of that curve is somewhere over here. We can't say with certainty where it is. Can't say with certainty where it is. It's just we think it's over here with a hell of a lot of confidence. It's over on this side somewhere. So it looks like we kind of suck at finding Iraq. If 62% of us can't find it, it means 2 out of 3 of us can't find it. Whatever. It's fine. I'm not saying it's meaningful. We could have just sampled badly, which is totally not criticizing your sampling techniques. That's why you take research methods classes eventually. Cool? Could we be wrong? Could we have just gotten ridiculously deviant data? Of course. Of course we could. What's the chance of us being wrong? Always, if the false positive, what's the chance of us being wrong in this class? 5%. It's always 5%. Because we're comparing that p-value to 5% every time. So as soon as we get, let's see where that would be about here, I think. As soon as we land in that tail, wherever we are in that tail, whether it's the 4.9% that we got in class, or whether it's the, whatever the hell this was, 0.00001 that we got today, as soon as it gets past that marker, we're going to say something's changed, and we think the averages are different. So that, the chance of us being wrong is always 5% based on that. As soon as it gets outside of that realm, we're going to say something changed, which means we're giving it a positive test result. Is there a chance that that 61% actually lives on this curve? Is there a chance that it lives on this curve? Is there a chance? Don't look at that number. It's misleading. Is there a chance that that 61%, i.e. that z equals 9.06, lives on this curve? Of course there is. It's just teeny tiny. Remember what it was from that last screen?
In fact, it's supposed to.
It basically, by the definition of that curve, it needs to be there, right? Now, technically speaking, Wendell brings up a good point. That curve goes on forever. Of course, left and right forever. Percentages eventually run out, don't they? I mean, if you think about it that way, percentages stop at 100. You can't go above 100%, no matter what Tomas told me this morning. 105%, I'm like, Tomas, dude, back off. So if that's not, if this is 20%, let's just call it 20%, make the math easy. If that's 20%, and roughly 60% is over here at 9 standard deviations, stands to reason that 100% is going to be out at 9 more, yeah, right? I mean, they're going to be linear. Every time you go a certain number of standard deviations, you pick up a certain number of percentages. So if we went 40 percentage points to get to here, if we go 40 more, we're going to get to 100%. Which means when Z is 18 standard deviations out, we hit 100%. Technically speaking, you can't go any further because you can't, I'm throwing markers now. Technically speaking, you can't go any further because you can't get past, thank you Megan, 100%. So what Michael brings up is a good point. Any statistic can land on that curve. But my definition, my mathematical definition of what they are, the tails go on forever, yes.
Well, I'm saying, it said Americans who don't know where Iraq is, and we're Americans.
Oh, I see what you're
We're
saying.
in that percentage is what I'm saying.
I see what you're saying. But my question is your average here, or is it somewhere else? The argument is it's probably somewhere else. And my question was, could we be on this curve? Sure, with almost no probability. There's always a chance you could be on the curve. It's just that you're measuring how likely it is that you were on the curve. I redid some of the, I got some of the old template sheets here, and I redid the template sheet with a couple minor adjustments. I made some room up here for you guys and so forth. I also put something different. It said give the p-value at number 8. In parentheses, I put a little something for you guys to think about. I put that is the probability your data agrees with the null hypothesis. Now, as the p-value gets smaller and smaller and smaller, that means your data is agreeing with the null hypothesis less and less and less, which means it's getting further and further and further away from that curve. Does that make sense? Hopefully that makes sense. I'm trying to drive home that point of what that p-value means, because we're going to be picking up basically a test a day from now for the rest of the course. And when I say a test, a different kind of test. This is testing proportions. Today we're going to test averages. Then we'll test 2 proportions and 2 averages, and then we'll do 3 proportions and 3 averages and 4 proportions. And it's not much more math. Actually, there's hardly any more math each step of the way. But every single one of them makes a decision based on that p-value. The smaller that thing gets, the further we're getting away, left or right, from this believable null hypothesis. And it gets harder to believe that the null hypothesis is correct the further we get away. Renee, go.
He answered my question.
Oh, did I? The fact that it's harder to believe it the further we get. Yeah, that's the point. I want to put a question on your question, is why do we use that 5% as a cutoff? And the cheap and easy answer is that's what's in the research journals right now. That's not a very good answer, just so you know. That's not a very good answer. But that's the one that is used basically in industry right now, is a 5% significance / 95% confidence. So we're going to keep using that because I feel remiss if I don't prep you guys for what you're walking into. Some of you have already walked into it. You've already been seeing these p-values of 5% or less. I want to talk more about that today as we go through our next hypothesis test too. But thank you guys for collecting more data. It was fantastic. Very surprising result. Very surprising. These are the ones you often read about. If this were like a true research study, these are the ones you're going to read about. The one we got yesterday, the 4.9%, no one would have ever published that p-value. Well, maybe they would have. It would have been made fun of, laughingly. Because they could put in the article, p is less than 5%, because it is less than 5%. But they're looking for slam dunk p-values like this. They're looking for things that are completely different. Not just arguably different because it gets over some pseudo-historical 5% line. They're looking for slam dunks like this. This is a truly significant change, 40 percentage points.
Because if
Yeah.
you round up, it's still 5%.
Yeah, but I mean, the point is that it's so close to 5%. If rounding is the only thing making your argument, that's like saying tucking my shirt is only going to get me my next job if I go to a job interview. It's kind of like, that's not really a meaningful data point. This is meaningful. There's something definitely interesting going on here. Cool? All right, very, very good, very, very good. Thank you for collecting more data. That made it very much more fun to talk about. Go back to your data sheet. Speaking of that, we're going to collect some of our own data today as well. But I did provide some for you to get us started into this next idea. Yeah, and we're going to keep going straight down the list. We'll have fun with this as we go through the rest of the course. Go ahead and read the bit about IQ scores after acute head trauma. After acute head trauma. Oh, here you go, JC. You got it. Grab some of these too. Yes, for sure. Grab a few of these. There we go. Grab a stack. Yes, those are the old ones. Looks like the new ones are more popular. It's good. I think they're cleaner, personally. I think they're cleaner.
Okay.
Shut this down so you guys get a